Welcome to my session about JDK not so hidden tools. My name is Andrzej Grzesik. I used to live in Krakow. I used to work in Krakow. Now I joined a wave of people living in London, and I'm happy living there since at least 2.5 years. You might recognize me from leading Polish Java user group, from a conference called Geekon, from Krakow Software Craftsmanship, from Krakow Hadoop user group, which is now called Data KRK. I have a Twitter, I have a blog, I have an email if you need to. This session is only 40 minutes long, so we'll try to go through all the material I have. If there is time for questions, then of course we'll try to do it. If there is no time for question, feel free to grab me or tweet or anything. And well, let's start with something motivating, of course. This is actually a huge fear of mine, that I'll be basically stupid. So I need to keep learning. So I need to keep digging. So when I see something, I need to understand how is it that the thing is working. So I need to understand what's under, and then what's under the thing under, and then one level deeper, one level deeper, one level deeper, like an infinite inception. But with computers, that's quite easy because you can just, well, keep debugging the compiling and, well, as much as you can. Especially with Java, there are so many layers of abstraction. It's just so awesome. So, having started, I know this conference has a Twitter handle, and I know I have a Twitter handle. Who here has Twitter? Can you raise your hands? 8, 9 Twitters in a room? 10? What? Just install Twitter, register, and try to tweet something. I think the organizer... Huh? Well, I know I'm in Poland and people don't like tweeting in here, but still, if you look at it from, well, how else are you going to say to the wide internet that this is, well, I'm having so much fun at JDD and you should come to this conference next year. This is hard otherwise. So, if you have any questions, just wave your hand. I'll try to I'll try to answer. Or if I find a question that is not really answerable, we'll do something else. This talk is about tools that you have in your Java. The motivation is for me to go through some of the tools to show you some of the capabilities. I will not provide in-depth explanation of every single tool in there because just there is no time. And also I respect you. You are very smart individuals. You know how to read manuals. I don't have to do it for you. You can do it in your own spare time when you have the need to use some specific feature of a tool. You can find it out on your own. I just wanted to highlight what tools are there already available in your JDK. Also, I'm basing my presentation on Oracle/OpenJDK. I'm not a user of IBMs or other JVMs out there. Just mentioning. And who here is on Java 1.6 or older? Raise your hands. Don't be afraid. 4, well, 5, 7. Okay, so you're 1.7 or newer. You win. That's awesome. Just so that you don't feel too bad, last year I met somebody who said that they are going to upgrade to 1.4. So yeah. In Java, you know that there is this mystical variable called Java home. Then you have the bin directory, and what do we have in there? Well, we have lots of binaries. What do they do? Well, they do a lot of stuff. We are not going to cover all of them because it's quite pointless. Some of them are quite old, some of them are new. Things are changing and things will be changing because Oracle is experimenting, it's adding, it's removing, it's, well, playing with what's there. You can see some awesome things like pack 200, because when you want your classes to be even smaller, there is, well, something for web services, there is something for RMI, and so on and so on. Quite boring. The important thing, there is 44 of them, which means there is a lot of tools, and usually you stick to Java and Java C. And I got curious one day, what else is there? Because some of the things, there must be a reason why there are so many tools in there. So, is anybody sleepy already? No. I hope you like the party. If there is one single thing that there is a single one thing that you want to remember out of this talk, please log your GC. And you can, well, I won't mind if you doze off and sleep, because logging GC is really important. It might save your body parts later in the day. If you're not sleepy, we'll move on. Logging GC, well, this is a sample set of flags. This is not the ultimate set of flags. Let me stress this. This is just an example set of flags. This changes from JDK release to JDK release, what you should use, what you shouldn't use. Please talk to somebody knowledgeable about adding, well, before you add that or before you decide on a set of flags. But do try to log your GC. What this does, it will take a record of your garbage collector activity. When it does a collection cycle, you'll see that in the log. Why is that important? Because if your application gets stuck for a couple of minutes, you will get to see when, how long, how much memory was reclaimed. So if you have an out of memory error, you will be able to say, okay, that's because, I don't know, maybe my heap is too small. Maybe my heap is too large, and that's why the GCs take so long. It's really, really helpful. It has saved my life in a number of cases, in a number of very strange cases. And also there is this caveat, well, a funny behavior of the JVM. It might throw an out of memory error if it's trying to reclaim memory for too much time. So if you will get an out of memory error because Java was trying to do a GC and it just couldn't find enough memory in enough time, and then maybe there is enough memory, but it would need more. So you'll get such information from this log. Please try to add it to your at least development servers, ideally production, so that when things go wrong, because they usually go wrong one day, you have something to work with. And now, when things actually do go wrong and you have to get your hands dirty, we'll go with command line tools, because first of all, if you work on a production server, rarely it is the case that you have some sort of a windowing system there, because of course, why would you? Second, probably you might be logging through a VPN, through a Bastion host to a secured environment through which you will jump to another data center in a place in which I cannot really tell, because I would have to kill you and all your families, because it's so secret. It doesn't even exist, probably. So command line tools, because you can get a lot of information about the Java processes and about what they do from the command line. Of course, if that's the case in your case, I envy. Where I come from, usually you cannot easily get 1,000 laptops configured by the same developer in a reasonable amount of time and ship them to places. So you have to build automation, rely on tooling, and actually work a bit harder. So the first question is, well, we hope to have a Java process. Let's say we have a Java HTTP server serving our awesome web shop. The first question is, does it run? What do you do on a normal operating system? Well, you do top, you do htop, you do ps with AUX or something else, depends on your flavor of Unix or Linux. And I'm saying Linux or Unix because I just don't use Windows for production servers. It's not because I believe they are not worthy, it's just because I don't use them, that's it. We can go into the less meritocratic and more heated discussion with a beer after this talk. Top htop for Java or PS for Java, well, yes, there is Java here, there is Java here, there is Java up there. It's not really super helpful because, well, there is a lot of things happening around there. It's a bit hard to navigate. There must be a better way, you could say. And yes, well, there is this saying that every known problem becomes a completely new problem when you add in Java. It's actually a saying of a friend who went from Ruby to Java, and then, yeah, let's sort the list in Java. Let's do something else in Java, and then he really loved it, and then he came back to Ruby. So instead of normal PS, in Java you do JPS. And somebody might tell you that JPS as a tool is really, really bad because it doesn't give you the packages, it doesn't give you all the flags. And then you can tell that person that they are slightly wrong or extremely wrong, and they were just too lazy to read the manuals. Because there is this awesome set of flags, which I also tend to tell. Everybody knows that Java loves memory. So JPS minus LVM, and we'll get this pretty informative set of things. Of course, this could go a bit further, but you get the idea. You get the main class, you get the params, you get the flags. Just to see what Java processes are running, I think that's usually good enough. Of course, there is a caveat. You will see the processes that you have file read access. How does JPS discover running JVMs? It looks at a directory under /tmp, and then every JVM that will be running will put some information. Well, it will announce itself through files lying in there. So if your TMP file system is locked, or you don't have any permissions in there, this might not work, because there are strange corporate environments happening from time to time in places. This might be happening. Root will, or should, see all of the JDK, well, JVM processes running, and from that you can, well, pretty much you can establish at least, is the process I'm looking at even running? Because that sometimes happens that something just starts to boot up and then dies and then nothing happens and monitoring doesn't pick it up. Or we have a lot of Java processes running on a system and it's a bit hard to say which one is which. So some more motivation, of course, but we'll not be looking at too much code today. Assuming we have our process running, we know the flags, we know, let's say we know the class path. You probably have run across a problem of class not defined. The class isn't there, but the class is there, or I don't know, a constant or something isn't there, but it's there. It's in my jars. And then you look at your probably web server that has 17 versions of log4j jar in its class path, and then, well, the question is the class really there or is it not? How can you verify? Of course, I am distrustful to all my computers. Or as somebody said once, trust but verify. There is an instruction called jar. You can use it to list things that sit in a jar file. So what it does, well, this just takes a random jar from my Maven repository and executes a jar -df. So you'll get to see all the files. So if the .class file isn't in the jar that you're looking at, it's not there. If it's there, yes, it's there. It doesn't say anything about the contents just yet, but sometimes that's enough. Especially if there are people who are playing with contents of jar files and, for example, extracting them and copying class files around or live updating jar files with newly compiled versions of classes. Yes, I've seen those crazy things happen, and this might save you. So I'm just mentioning jar is a useful tool to understand what's lying in which file. How do classes happen? Of course, they happen with Java C. Everybody knows that. Has anybody been compiling their classes manually from the command line? Just, yeah. At the very beginning, yes. Most tutorials mention it. Well, my personal start was actually compiling things through Netbeans, so I didn't do it at first. I discovered it later when I was investigating what's happening. How is it that I think, what is this ant thing doing down under the hood? Yeah, Java C is just the compiler. But then what you might want to look at is what is the product of a compilation? Or later, when something isn't working, what was the product of the compilation that happened later, much later? What you get is a class file, which means things compiled into bytecode, and you would like to understand what's actually sitting in the source code that your server is trying to load. So this is just some nonsense code. I've written it. It's probably very nonsense or extremely nonsense. It doesn't do anything important, but it has a constant. And as you know, with constants in Java, compiler is trying to be very smart and nice, and it optimizes them, as in it replaces places referencing them to the actual value of the constant. So if you change the constant and then you recompile just one class, and the constant was used elsewhere, well, you might have a problem. How do you find out if you have this problem? Or how can you actually troubleshoot such a situation? Well, you can use Java P, which will allow you to see the bytecode. Look at the methods if you're really interested, and, well, see some other information about the class files. So first of all, what you see up there, you see when the file was last modified, which is usually very useful if you're compiling and updating a class and the thing doesn't seem to be picking it up. Okay, so let's see what's on the other side, and then you see something edited in, let's say, 2011. That happens. Then you see an MD5, that's quite easy. Then you see a major minor version, which points at the version of the JVM that this is destined to run at. If you've seen an error mentioning the wrong version of major.minor, yes, you're hitting the wrong Java version, which means, well, it will not work. And then you get to see the constants that have been used in the compilation. So I am not going to explain what the layout of a class file is because, well, there are excellent articles available about it online. that's not the intent of this talk, but I just wanted to show that you can verify it with a simple command line tool that your JDK already has, and see where there is a string that's saying awesome referenced in this class file. So if you change that awesome to, I don't know, amazing, and then something still prints awesome, you might be able to debug it this way. This is pretty low level. This is pretty desperate when you're looking for a solution to a problem, but you might need it. I've actually needed it a couple of times. This has saved me, so hence you might as well. Let's look at another thing called jinfo. What does jinfo do? Well, we can have a demo. So sorry for that. Oops. So what jinfo will do, it will show you all the flags that are running within a JDK or a JVM process. So you'll see all the system properties that have been loaded. You'll see, well, that's this is the Java JVM, this is the JVM version, this is something else and something else and something else. All the flags basically. Why is that important? You get to see all the VM flags. So if you're passing some custom flag like Java zone level equals amazing, or JDD level equals more amazing, or there is a host, a proxy configured, or you would like to see what Java home you're using for that specific process, you might get to see that. When is that important? For example, if you have a very convoluted runtime strategy of processes running processes, again, like Inception, and you get to see a lot of Javas, and your operating system might have a lot of JDKs installed, and then things like to get funny when every single thing runs with a different set of settings and with a different JDK. It's a good practice to establish a baseline and then to remove one changing thing from the possible solution to your problem. This allows you to at least eliminate, to at least be sure what is it running with, which version of the JDK, because you might get different, funny problems there. You get to see all the flags, as you've seen before. You can see just a very specific flag if you're interested, and some of the flags can even be changed during runtime. So if you want to, for example, change the way GC logging gets done, you can do it. One thing that I need to stress out in here is the set of flags that you can change during runtime is changing. So from one release to the other, that list is getting longer and longer. So you can change flags. You can change a different set of flags. So it would be the best source of that information is probably the release notes or the source code of the release of the JDK that you're using. So no ultimate list, it's just not possible because next release will invalidate it, and that's pointless. Moving on, PMAP. Anybody used it on Linux? Nobody? One. Yay. What does JMAP do? JMAP allows you to make a heap dump of your process. Why is that a useful thing? Well, imagine you have, let's say, a big server running things, and you're wondering, do we really need that much memory, or do we have a memory leak? How do you want to make sure that it's not the memory leak case? Well, you can take a dump of your memory and then just examine what's in there. I'm going to run this very simple script just to get a heap dump. So you don't have to copy that. The slides will be available. You will be able to copy and paste that into your terminals later. What we'll get out of here is a heap with a date.bin file. And okay, awesome. We have a heap dump. What do we do with that? Well, there is another very useful tool called JHAT. First, so we have a heap dump. The important thing is here. JHAT, when given an argument of a heap dump, is starting an HTTP server, which means you get a very, very basic web interface. Which means this is a tool that you can use through even a very crude browser like Lynx, or if you're desperate, you can use curl or do something else. And you can see what classes have been loaded. That's not really so important. You can see instance counts. If you've been using a profiler before, you know what that's going to show. How many instances? That's not really the cool thing. The cool thing is here. There is a language called Object Query Language, which allows you to query the heap dump that you have. There is the help is built in, and it's an SQL-like language, which means you're probably already familiar with that to some level. So, well, we can select all the strings where value is larger than 100. Well, length is larger than 100. Let's see how many strings like that we have. Well, we have a couple. Am I lying, or let's execute something different? Yes, it works. You can read the manuals yourself. And have you been using the Netbeans Profiler, for example, or have you been taking heap dumps with JVisualVM? Yes, a couple of people have. Have you taken a peek at OQL? Yes. It's actually, OQL is the very same OQL that you will get in the Netbeans Profiler and in the JVisualVM. It's the very same implementation even. So it's a very useful tool to learn. And the cool thing is, I've shown you that it exposes an HTTP endpoint. And as you can see, the query that I get to execute is passed in the URL. So if you want to make some level of automated or a very simple set of checks that you, for example, have a pattern that if this is kind of the thing that I get in my heap that hints that there might be a memory leak, you can do that. And the OQL that you will learn is, there is a lot of examples of OQL queries that you can use and run against your heaps. So it's quite handy to know of it. Caveats. First of all, JHAT needs to load up the heap. If you have a 60 gig heap, it needs at least 60 gigs of RAM to load it. That's one. If you load it in, let's say, Netbeans Profiler or JVisualVM, you will need more, because Netbeans Profiler will do an index of that, which the index takes usually a rule. What I take as a rule of thumb is a 25% extra. So if you have a production server, you will need another production server class machine to be able to examine the heap. The good thing is you can take a heap dump and then you can go away from the production server. So the production server can be left to its own doings, and then you can analyze it offline. You can do it on your, super powerful desktop, or spin up an instance on your favorite cloud provider and then do the analysis there, and then you don't really have to impact production. I've had somebody was asking, because when they analyze the heap of a running Elasticsearch cluster, they get very long pauses. Well, yes, because the heaps are large, but you shouldn't do it on a live thing. You should take the heap dump and do it offline. Maybe take a couple of heap dumps, maybe then try to examine what the difference is, but don't do it live, because it's going to impact, it's going to kill your performance, not impact. Demo. You've seen the demo. I really encourage you to try it, because it's quite cool. It's simple. It doesn't show you too much because the UI is extremely not fancy as much as you can imagine. But because it's so crude, it also means that it doesn't need a lot of resources, which means you get to use it on a very crude machine, even if the connection is poor, even if that's telnet over an HTTP tunnel over something else. You still get to use that. Stack traces. The question is, how do you get a stack trace in Java? Anybody? Somebody says throw an exception. Yes, that is a way for a single thread. That's a good way. How do you get all the stack traces of every single thread running in a JVM? JStack. Somebody's saying JStack. There is also another way, a very Linux way. Kill -3. Yay. You guys know your stuff. That's good. We can kill this. And of course, there is a trick with kill -3. So I'm just showing you what the output of the stdout.log is, because this will be easier just to have lines scrolling over here. So let's do a kill -3. And I mentioned stdout, which means, yes, this goes to stdout. If you're running in some kind of a server, some kind of a container wrapper, let's say a Tomcat, or there are some applications living in the same JVM, stdout might be already polluted. It also might have been redirected to a dev null, because that's a very common practice for people who don't like configuring the logging frameworks, which means all this information that's quite neat will end up in dev null. So the alternative, as somebody already said, is to use JStack. JStack will give you stack traces of all the threads running in a particular JVM. And just before you scream awesome, it's unfortunately not that awesome. There is a couple of caveats here. Again, kill -3, we already seen it. Caveats to JStack is it's not a snapshot like this. If you thought that JStack is actually is holding everything and running like a blade through all the threads, no. I'm very sorry. I'm disappointing you. JVM might be disappointing you at this moment. It's not like that. It stops all the threads, takes one stack trace, then lets them all run, then stops all the threads again, takes one more stack trace, and so on and so on and so on. Only at save points, if you know what save points are, one thread at a time. Which means in reality, what you get is something more like that. Which is not a problem if you have long-running transactions, which is a problem if you have very short-lived things. Because if you're trying to debug methods that take a couple of milliseconds or shorter to run, you might get information that doesn't make any sense. This is important. This needs to be stressed out whenever somebody mentions JStack, because you might get results that don't really make sense. So important things in here, you also get to see the thread ID. And as you can see by the 0x at the beginning, it's in hex, so you can't just copy paste to your PS scripts just to correlate threads versus Java threads versus system level threads, but those numbers when converted will align. So if you do htop with a tree, you will see that those threads actually match up. If you have, for example, a very specific thread taking up all the memory, all the CPU, you can actually figure out which one is it by running JStack and then seeing which thread is, well, that is. Second thing that is important in here, you can see that waiting on object monitor. So if there are a couple of threads waiting on a single monitor, you will see which one that is. Which also means JStack is now smart enough to tell you that probably they might have a deadlock because they are waiting on each another's monitor. And I'm saying might because, as I said, this is not a slice. This is a set of slices, so the information in there might not really make sense. Third thing, or the last useful thing, is this thing up here. That's the thread name. The good or the important part about the thread name is you can set it. If you have a long-running transaction, you can do thread, current thread. You can set the name to something indicating what part of business processing it's doing. So you can set your transaction ID, you can set your, I don't know, customer name there, customer key, something that allows you to correlate the work that's being done with the thread name. So I've seen people that have been running frequent, as in couple of stack traces per minute per JVM, checks like that, just to aggregate how much time every transaction takes. For them, this was good because transactions in their system were taking matters, well, somewhere roughly around an hour, sometimes more, a couple of hours. So this is a viable way of monitoring that in such situations. If you have something very short, or if you're running, let's say, Akka, this will not work because then, well, you don't get to stick to your threads. This is something beyond your control. But this might be a useful technique. This might help your debugging. So I prefer to mention that. Demo, we've already seen that. But there is one more thing in here. You get to see all the JVM threads. So you get to see the compiler threads. So if you know what these are, well, you know what I'm talking about. If not, well, you can read about it later. You get to see the finalizer thread. You get to see the GC threads in here. So if there is a lot of GCing happening in your JVM, or you think that there is a lot of GCing, you can actually correlate whether the threads that would be running the GC are the ones that are occupying the CPU, or those are different threads. You get, yeah, I think that's enough. Now, JSTAT. What is JSTAT? Well, JSTAT is a tool that allows you to collect metrics with some options over an interval with a count of how many times you want to do that. If you're familiar with VMstat or IOstat on Linux-based or Unix-based machines, you know what I'm talking about, or you have a very good intuition of what I'm talking about. On Windows, I have no idea what that would be equivalent to. But that's only because I don't know how to use Windows. Why is that not working? Okay. We'll just launch a process in there, and what we'll get is we can collect metrics. They get spin out every couple of lines. Then we get to get the repeated header in case you're getting a couple of metrics at the same time in the same console, or maybe you're redirecting that to a file and you want to get it every single time because, well, somebody else might not have updated their output. The question that might be crossing your minds is, how do I know that I should be typing -gc here, and what's the format of that, and what do I get out of here? And that's the right question to ask. The custom options, the options that you get to use, are all listed in the sources of OpenJDK. So there is a lot of them. You can read it at home because the list is just too long to try to read it aloud before lunch. Why is that important? Well, because you can construct your custom formats. And I could tell you how to do it, but I'm a lazy person. So I'll do something better. I'll just recommend you look up Jakub Kubryński, another member of the JDD program committee. He has actually written an article. It's available on DZone, how you can use JSTAT to have custom metric sets or to have custom formats for JSTAT. It's on DZone. This link will be included in the references in the slides from this talk. So you can have that on a very custom level, and the building blocks again are in here, which is, well, pretty amazing, because then you get to see, exactly the information you want, exactly in the format you want, and there is, well, almost nothing stopping you. Moving on, JSTAT-D is a tool that allows you to expose information of JSTAT from a computer over a socket, but I will not be running a demo because I've upgraded to the latest and greatest El Capitan, and it kind of doesn't work. Just mentioning that it's there. And now, a bit of fresh air. Oracle has luckily has noticed that there is a lot of tools that kind of repeat themselves inside the JDK. So instead of having to learn all kinds of tools, there is a thing called JCMD that's supposed to be the one-stop shop for all your command line needs. By default, it works like JPS, and by default, now it shows the package, well, the fully qualified class name. Let's do JCMD help. Yes, I don't know what to do. So let's take a process, and then let's say help. And this will tell me what commands are available. And you might ask, why? Why do I get to see what commands are available? The answer is very simple, because as the JVM gets developed, more and more options are being enabled, more and more options are being exposed. So in some older JVMs, this list will be very, very short. In a 1.8, I think that's underscore 60, you get to see so many. And you get to see also the Java flight recorder here. You can force a GC run, you can take a heap dump from here, you can see what the VM uptime is, you can see the flags, you can see the system properties, and you might be asking, well, this seems like a duplication of what we've seen before in other tools, and yes, that is duplication, because what this tool uses is exactly the same way to get that information as the tools that you've seen before. This is just reusing the same information channels that you get to see when you are, for example, opening that in Visual VM. Let's take a thread print. We've seen that being printed out before. Now the question is, why do I show you JCMD at the very end? Because JCMD has been added to the JVM, to the JDK in Java 1.7. So if somebody has to work with something that is not Java 1.7, you will not have JCMD, or if you are running a very early 1.7, you might not get all the options. So I prefer to show you all the tools that are available and then go into the one-stop shop so that you know what the building blocks are. And now that you've already well seen, you already should feel familiar. So JCMD, quite cool, gets to do all the things that we've done before. And now we can finally go to something visual, something that will have a UI. Why at the very end? Because, of course, I love my command line, but also because this sometimes is needed. So we get to see what processes are running. We can connect to one. We get to see the system properties. We get to see the JVM arguments. So now you know that you don't need to launch a UI. You don't need to have X window or your favorite equivalent installed to be able to see that. You get to see some sort of activity monitor. You get to see what threads are running. You can take a thread dump. You can launch Profiler. This will be the same Profiler that is running inside NetBeans. And there is one thing that I really like showing to people, that you have to install as a plugin to the default install of JVisual VM, which is called Visual GC. Oh, sorry. You have to go to Tools, Plugins. Then you go to Available. Then you go and look up something called Visual GC, as I already have that installed here because I cannot rely on that network. And then you get to see the GC activity. Why is that awesome? Because it's animated. And some people say that a picture is worth 1,000 words. To me, an animated diagram of GC activity is worth, I have no idea how many more words compared to a static GC log that you would have to analyze with something else. Of course, if I we can take a heap dump. We get to use the OQL. We've seen the OQL. We've seen OQL before. That's the same OQL that you've seen there before. Those tools are the same because they are just reusing the same code base. It's just them being exposed in a different tool. You get to see the classes. You get to see how much how do I invoke OQL? Yes, there is a query editor and there is the query results window. So you just type select. I'll just copy something that I can hope to work because, and yep. And of course you can type a bit more and more and more in there. You get to see at the classes. You get to see at the instances if you define which classes you're interested in, and then you can see, of course, all the insights with OQL. With a heap dump, you can actually see what fields each class has and what reference, and you can actually traverse the heap. And then, because it's a language, it means that you actually can do a tree traversal or on your object graph and then analyze and extract the information that you need. Also, it means that if somebody grabs your heap dump, they might extract a lot of important business information, but that's a separate story. Coming back to our presentation, do you have any questions?